Let's find out the moment of resistance of composite section. Now since we have the composite section whose centroidal axis passes through the centroidal axis of each of the wood and steel section, the moment of resistance of composite section is given as moment of resistance of steel plus moment of resistance of wood. This is equal to sigma max upon y max of steel into I of steel plus sigma max upon y max of wood into I of wood. Now sigma max of steel we found out, sigma max of wood is given in the problem, and we know the y max of steel and y max of wood, which is equal and is equal to half of this depth, and we can calculate the I of steel and wood section from the given diagram of this section. So we can calculate the moment of resistance of composite section. So upon substituting the values, we get sigma max of steel is 140 upon y max is 200 divided by 2 equal to 100 multiplied by I of steel is, if we see there are two steel sections whose centroidal axis passes through the same centroidal axis of composite section, so the moment of inertia of the two section could be given as 2 multiplied by simple BD cube by 12, which is B is 10 mm and D is 200 mm, so 200 cube upon 12. So this gives the moment of inertia of two steel sections about the centroidal axis of the composite section, plus sigma max of wood is 7 upon y max is same 100 mm, and I of wood is given as BD cube by 12, that is 100 into 200 cube by 12. So upon solving, we get the moment of resistance of this composite section as 23.33 into 10 to the power 6 Newton mm. So this is equivalent to 23.33 kilonewton meter. So this is our second answer, and this was your first answer. So with this, our problem is solved. Optionally, we can also plot the variation of bending stresses for this composite section, which will look like as shown in the figure. We see that at the extreme top layer above the neutral axis, where your section is subjected to compression, your maximum bending stress under compression in the wood is 7 Newton per mm square, whereas at the same level, maximum compressive stress in steel is 140 Newton per mm square. Now since our section is totally symmetrical about the centroidal axis, the corresponding stresses in wood and steel under tension will be of same magnitudes as given in the compression. So with this, our problem is solved. Thanks for watching in 5 minutes.